In this lesson on sequences and series, we are having a look at the arithmetic series. A series is formed when you add the terms of a sequence, and that can also be called the sum. Now, in this sequence that we have, we can say let's add the first two terms. That will give us 16. Or we can say let's add the first three terms to get 27, and we can continue like that. Now we add a symbol to this and we say let the sum of the first two be 16, and then the sum of the first three terms will be 27. Here are all the symbols that we already know. A is the first term, N is the position of the term, D the constant difference in an arithmetic sequence, R the constant ratio in a geometric sequence, and Tn the value of a specific term. Now we can add Sn as the sum of n terms. Now it is important to realize that n in Tn and Sn isn't exactly the same. In Tn, it is the position of that specific term, and in Sn, it is the number of terms being added. In this lesson, we are focusing on the arithmetic series, and this means we will be working with D, a constant difference. Now, instead of adding every single term when we want to calculate a sum, we have two formulas that we can use. If you want to see how these formulas are proved, you can watch lesson 5 of sequences and series. In these formulas, we already know all the different variables. The only symbol we do not know yet is the L, and this is for the last term's value. Example 1. Calculate the sum of the arithmetic series 3, 7, 11 up to 30 terms. This is an arithmetic series, so we know there's a constant difference, and in this case, that is adding 4 every time. We already know that A, the first term, is 3, and we want to calculate the sum of 30 terms, so that's n. Now we can substitute into our sum formula. So we want to calculate the sum of 30 terms, so n becomes 30. A is our first term, 3. Once again, n is 30, and our constant difference is 4. And this will give us 1,830, which means that if we add the first 30 terms in this series, we will have an answer of 1,830. Example 2. Consider the series and calculate the sum of the series. Now, we don't know which type of series it is yet, so that is where we start. If you look closer, you'll see that you subtract a half every time. So there's a constant difference, which means we have an arithmetic series. To calculate the sum, we need A, N, and D. We know that A is minus 1, and we know that D is minus a half, but we do not know how many terms we need to add up. For this, we're going to focus on the term right at the end, the minus 16. We know the last term's value, that means Tn, is minus 16. So we're going to start off using the Tn formula for an arithmetic series. We know that the value is minus 16, the first term is minus 1, and we also know that D is minus a half. Now I'm going to add the 1 on the left, so it will become minus 15. And on the right, n minus 1 is multiplied by minus a half. So now I'm going to divide by minus a half to get 30 on the left and n minus 1 on the right. So that means n is 31. So now that we know that n is 31, we can go and substitute into the sum formula to calculate the sum of the series. I'm going to calculate the sum of 31 terms. And that will give us minus 527 over 2. Now, of course, because we had the minus 16, the last term, we could have also used the other formula. If we substitute into this formula, we will get exactly the same answer. Example 3. How many terms of the arithmetic series will add up to 1,700? Now, because they say it's arithmetic series, we already know that we are going to work with a formula with a D in. And we can see here that that constant difference is 5. Then they say that it will add up to 1,700, so that will be our sum. So we know that A is 8, D is 5, and the sum is 1,700. So we can go and substitute into our sum formula. Then it will look like this. Now, to get rid of the divided by 2 on the right, I'm going to multiply by 2 on the left to get 3,400. And on the right, we can simplify inside the bracket to get 16 plus 5n minus 5. Now we can simplify inside that bracket again. Next, we can multiply in n to get 5n squared plus 11n, and then also subtract the 3,400. Now we have a quadratic equation, which means we can either factorize or use the formula to solve n. So n can be 25 or n can be minus 136 over 5. But now, because n is the number of terms, it has to be a natural number. The minus 136 over 5 is not valid for this question. And that means that the first 25 terms added up will be 1,700. Example 4. Consider the arithmetic series. Calculate the smallest value of n for which the sum will be bigger than 300. Of course, as we keep adding terms to a series, the sum will become bigger and bigger. They want us to calculate when this sum will be bigger than 300 for the first time. So, to know this, we need to know when this sum will be 300. So, we already know that A is minus 4, and we already know that D is 3. We also know that the sum that we are focusing on is 300. I'm going to substitute what we know into the sum formula. It will then look like this. Once again, to get rid of the divided by 2, I'm going to multiply by 2 and get 600 on the left. And I'm going to simplify inside my bracket. I'm going to simplify further and then multiply in. Next, I'm going to substitute into the quadratic formula and solve n to get 16,09, or n is minus 12,43. And now, of course, the minus 12,43 once again is not valid. And now we need to think about this 16,09. If we calculate the sum of the first 16 terms, we will get something a bit smaller than 300. If we now calculate the sum of 17, it will be something just bigger than 300. We need to calculate the smallest value for which the sum will be bigger than 300. So the first time the value will be bigger than 300 is when we add 17 terms.